At glance, features and functions of those software, they provide a proven technology for design and sustaining transportation infrastructure. So this software includes or based on the geometric design principles, and they store the rules and relationship between geometric elements. They create horizontal and vertical geometry by PI method and by individual elements, create circular and parabolic vertical curves, support tangential and non-tangential curves. Define curves by radii, degree of curvature, and pass-through points. The software enables you to edit the information, delete it, and join elements that is vitally important for geometric design, whether it's a vertical geometry or horizontal geometry. Check geometry integrity tool, review and report geometry, can provide a report, and annotate dynamically and automatically and displayed three-dimensional geometry. It provides interactive coordinated geometric design using robust and interactive geometric tools. Create and edit, move and delete geometry dynamically. Locate intersections, fit curves, create right-of-way and various layouts. Generate geometric transformations and create horizontal geometry reports in a variety of formats. It provides the integrated mapping by it provides details that use the interoperability. In other words, you can use the information provided by, let's say, Bentley software, and you can use it in, you can convert it and use it in the other software. Browse and analyze the data. Map thematically and generate reports. What is all required? You need to have a starting point. Any design starts from the survey and the survey base and the data acquisition. The software will read and write standard data formats automatically for raw survey data from all major survey equipment. It will upload to data collectors for construction stakeout. Merge surfaces automatically. Update surface data dynamically. Software will create terrain models. Import three-dimensional graphical data, import standard data formats automatically, ensure intelligent models with a terrain model stored as a DGN element, which stands for the design element, and use across disciplines via reference files. As I mentioned a number of times, the geometric design should be looked at the 2 dimensions and the 3 dimensions, and the various software are able to convert the 2-dimensional model into the 3-dimensional model, and it will create intelligent 3D model. The software will model intelligent civil features for ditches, trees, culverts, and etc. Pass survey intelligence to the 3-dimensional model. Added context-sensitive intelligent features, extend, trim, and intersect features. DTM analysis, which stands for Digital Terrain Model, will create contours from data points accounting for breaks, random points, voids, edges, and other criteria. Control maximum length of triangles. Control density of points on on linear features for optimal surface presentation, and display cut and fill delineation, view and edit feature properties. It is vitally important for you to understand the capability of the software. Throughout the course, you haven't had a chance to use the software for itself, but as soon as you will record what the software able to do and how the software can facilitate your design and make your time spent on the design more effective, you will make an effort to learn about these softwares. I'm not suggesting to learn about the particular software. I'm only suggesting to familiarize yourself, because depending on the road agency, depending the country you're going to work in, it may have a certain preferences for a particular software. Okay, but all the softwares based on the fundamentals, design considerations, design inputs that I have provided through my lectures. Modeling. The softwares will model multiple scenarios, edit design visually, create models automatically, generate material assignments automatically, update models dynamically and automatically, and preserve designer's intent. It's a great tool. It may create different platforms that will allow you to check whether particular features or stop inside distances has been achieved, not just in the longitudinal areas, but you can actually look at the impact, lateral impact, and this is where the platforms will become a very useful tool to look at the roadside hazards. Utilize two-dimensional and three-dimensional integration. Use a rule-based superelevation. We talked a lot about the superelevation. Utilize dynamic cross-section elements. Generate plan-ready cross-sections. It will allow you, upon development of the digital terrain model, to generate the cross-sections automatically rather than producing them manually on an individual basis. Control components display via rules set up by you and adhere to AASHTO and other regional standards. The AASHTO is American organization, American Association of Highway and Transport Officials, which is a similar organization as we have in Australia, and it's called Austroads. Okay, and other regional standards. Profile and cross-sections. It will create and generate cross-sections and profiles along alignments, graphics, and between the points. Will include drainage structures and utilities, include vertical alignments in existing and proposed surfaces, apply user-defined annotations of points and segments. All this will make sense to you as soon as you will make an effort to, more sense to you as soon as you will make an effort to learn about the software. It's quite a lengthy process, okay? To become efficient in a design software, you may need to invest a couple of years of your time. The software will cut cross sections and under the angles, will create a custom cross sections, update cross sections and profiles, and generate earthworks volumes. Open Roads technology provides a common technology for In-Roads. Okay, In-Roads is one of the softwares, and the Open Roads technology offers immersive interaction of survey geometry, terrain modeling, corridor modeling, dynamic cross sections, civil cells, design intent, design time visualization. Okay, I want to finalize my lecture on a note that I hope you'll find it's interesting. It is challenging. It is quite challenging to learn over the 4 hours about the fundamental principles of the design for major urban roads. There's a lot of information has been provided to you. If you missed anything, you've got a chance to either to listen again to the lecture, or I strongly recommend you to read the Austroads design guidelines, in particular part number 3. Alternatively, if you will have any further queries, you should contact me via tutors that are allocated to the subject. Thank you for your patience. I didn't have a chance to interact with you, but I'm sure one day we'll meet and you will have an opportunity to talk to me face to face. Good luck, and thank you for your effort to listen to my lecture.